Welcome to another quick and dirty tutorial on the Unity UI system. In this one we're going to create a simple drag and drop inventory system. Along the way we'll learn about the new event system and all of the coolness that can do. We'll see replacements for send methods by creating our own custom events, and we'll also use a lot of the events that Unity has already created for us. First off, we'll start with a blank project. The only items I have imported to this project are a few pieces of artwork. Note that because we're using them with the UI system, we've imported them as sprites. Sprites for the 2D and UI system. So first off, we'll create a panel. From the UI menu, note that with the panel it automatically creates a canvas and an event system, both of which are necessary later. We'll get rid of the image because we don't want that. It's worth noting if you want to use the events, you have to have an event system. Alright, so let's resize that down, and then we'll add a component from the layout, and we'll add a grid layout group. A grid layout group is going to automatically arrange all of its children in a grid. You can see the parameters there. Cell size of 100 by 100 looks pretty good. Right, we'll go ahead and create a child of that. See, it's automatically put it to 100 by 100 and it's arranged in the top left. We'll call that our slot. And let's center these slots. So we can do that by just changing the parameters on the grid layout group. There we go, nice and simple. Right, we're going to do the same thing with this, and that we're going to add a grid layout so it will automatically arrange any objects that are added to it as children. We'll make the cell size on this 90 by 90, just make it slightly smaller than its parent. Then we'll add an image. We'll drag in one of our sprites. We'll give it a color. Let's make this yellow. That looks yellow enough to me. We'll give it a name. Since we're making games, we'll call it Gold Helm. It sounds a little bit cooler than Yellow Helm. Alright, zooming in on that, you can see it hasn't centered it in that slot. So if we go back to the slot, and again to the grid layout group, and if we put the child alignment into the middle center, there we go, and that'll position it nicely for us. We'll make that, we also need to add another component to it. This one we're going to add is the canvas group. The canvas group gives us the interactable and the blocks raycast. So this lets us control how it's going to interact with the raycaster and hence the event system. Very useful way to stop them from blocking raycasts. We'll make that a prefab, and by the magic of video editing, we'll make all of our other pieces of art into prefabs at the same time. We'll go ahead and make a few slots there. And then we'll duplicate the entire panel. We'll add a little bit of spacing, pretty it up a little bit. Right, let's move this down. Let's give this one some more slots. basically making a sort of backpack system down the bottom and equipped items up the top. And let's resize this a little bit. Drop it in the center. Okay, and fast forward, we will add all of our items to our backpack. Then we'll select all of our items. We're going to add a component. We'll make a new script, and we're going to call this drag handler. Now I'm going to spell it wrong. You have an option to spell it wrong, or you can spell it correctly. I would suggest spelling it correctly for readability. Let's open MonoDevelop and edit that script. First up, we need to add using Unity Engine .event systems. The event systems is really quite powerful, and it's one of the most common classes I'm now importing to almost all of my scripts. There's 3 interfaces that we need to apply or implement from the event systems namespace. First is iBegin drag handler. The second is iDrag handler, and you can probably guess the third is iEndDrag handler. So between the 3 of those, iBeginDrag is called at the start of a drag, iDrag is called every frame of a drag, and iEndDrag is called when we finish the drag. It's also worth noting we've got this cool little feature of MonoDevelop where we can just right click on it, go to the refractor menu and choose Implement Interface, and it automatically puts in all of your boilerplate code that you're required to put in by the interface. We'll add a public static variable. This is going to be the game object that's being dragged. Normally I'm not a big fan of statics, but in this case it actually makes sense because we're only ever going to let the user drag one item at a time. So the first thing we want to do in our begin drag method is set that item being dragged to the current game object. We're also going to set up a vector to store the start position of that game object. This is basically so that if the user drags it to an invalid location, it'll pop back to where it started from. We're just going to set the start position equal to the transform position. We'll drop down to our end drag. Again, deleting the exception. We'll set the item being dragged to null. And then we'll set the transform position back to its start position. It's basically dragging it out. Right, now in the on drag, this is where we actually need to change the transform position every frame. So we'll go transform position is input.mouse position. You can also use the pointer event data if you like. Alright, we'll save all of that. Always pays to drop back and do a test. Make sure you're getting expected behavior. And we are. Drags it around and it bounces back to where we are. Alright, we'll set up another variable, a transform, called start parent. And so at the start we're just going to record what parent it is. We'll use this to determine if the object has been dropped into a new slot. So basically if the parent has changed, then we don't want it to snap back to its original position. We want it to go to its new position. You probably spotted the typo there already. That should be equal to rather than not equal to, and I'll correct that in a moment. Again, a very good reason why you should test frequently in Unity. We're also going to grab that canvas group that we added, and we're going to set it so that it no longer blocks raycasts while we're dragging. This allows us to pass events through the item that's being dragged and back to the item, to whatever items are behind it. Of course, we don't want that to be true once we've finished dragging. So once we've finished dragging, we'll set blocks raycast back to true. I'll correct that equals. Now we'll drop back to Unity. We'll grab our slots. We'll add a component to the slots. And for lack of creativity, I'll just call it slot. If we edit this script, again we want to be using the Unity engine.event system namespace. Again, we don't want start or update. Start's a fine method to use. Update you should avoid using whenever possible. We're going to set a public game object, which is the item. We're actually going to use properties on this one. Properties are pretty nifty. They allow you to define some custom methods that are called, but they get treated as a variable from outside the script. So all we're going to say is if it has a child, so if its child count is greater than 0, it's going to return the first child. So I'll just return getChild0. And if it doesn't have an item, it's just going to return null. You could go around writing all of this code in the various places where you want to use the item, but it makes it easier to write it all in one property. Right, the interface we're going to use here is called iDropHandler. So the drag handlers go on the object that's being dragged. The drop handler goes onto the receiving object. Again, we can right click and implement that. What we're going to do is first we're going to do a check to make sure we don't already have an item. If we've already got an item, we don't want to accept the new item. If we don't have an item, we're going to go to the drag handler. We're going to grab that static variable, item being dragged. We're going to grab its transform, and we're going to set its parent to the current transform. So basically each slot, if an item's dragged over it and it doesn't have an item already, it'll grab the item that's dropped on it. We'll save that. I've just spotted an error. This function returns this property returns a game object, whereas getChild returns a transform. So we need to put .gameObject. Quick test in Unity, as you can see, drag it. If we put it in a slot, it ends up in a slot. If we put it in empty space, it bounces back. If we put it on top of another one, it bounces back. Now we'll grab our canvas. We'll add a script to that. And this is the inventory script. This is the script that's actually going to control what we have in our inventory. How exactly you implement inventory depends a lot on your game. So in this one, all we're going to do is display a text showing which items are actually equipped, or which items are in the top box. and it's just going to display it in the text. Again, we're going to add using Unity Engine.Event Systems, so we can have access to all of those interfaces. We don't actually have an interface that does what we want, which is basically inform the inventory when something is changed below it. So we're going to create one. We'll add it to the Unity Engine Event Systems namespace. I like to do this just to keep all of the interfaces in the same place. You don't have to. This will work in whatever namespace you put it in. So we'll declare a public interface I has changed, and this inherits from the I event system handler. You must inherit from I event system handler in order to use the event system. All it's going to do is have a method that says has changed. Now we'll go ahead and implement that. There we go, brought up our boilerplate code. We'll call has changed and start as well. That way we don't have to worry about what our text start as, because every time we load it, we'll automatically call that. What we're going to do here is use a string builder to build our string. The reason I'm using a string builder rather than just using the plus is because when you do multiple pluses in a loop, it can really chew up memory for the garbage collector, and you typically want to avoid garbage collection as much as possible. So we're just going to make our string builder. It's called builder, and it's a new string builder. We're going to use the append method. Append is the method that adds a string to our string builder. And like I said, it does this in an efficient way that avoids garbage collection. So we'll loop through with for each, and we'll go through each slot transform in slots. Of course, in order to do that, we have to declare our variable slots. So we'll use serialize field for a transform, and we'll just call that slots. We can assign that via the inspector. Always use serialize field instead of public unless you want to access it from other scripts. So we'll create a game object variable called item, and that's going to be based on the slot transform, on getting the actual slot component that's attached, and then calling that item property that we built before. Remember, the item property will return the game object if there is one, or it will return null if there is nothing in that slot. So of course we'll do a null check and say if we actually get an item returned, then we want to append that item to our string. And we'll also append our little separator hyphen, just to make things a little bit neater. Now we want to do something with that string that we've just created. So we'll create a text variable, and we'll just call it inventory text, and we will send our string to the text on that. Of course, in order to use a text component, we've got to add using Unity Engine.ui at the top of our script. We go inventory text equals builder.toString. ToString is just the method to get the string that we've built and all of those appends out. Alright, now we haven't called has changed from anywhere, so let's drop to our slot. We'll drop down into the same place where we grab a new item. And we're going to call execute events dot execute hierarchy. Execute hierarchy calls it on every game object above the one that you've called it on until it finds something that can actually handle it. We'll put our iHasChanged interface in there. We'll pass it the current game object to start with. We'll pass it null for data. And then we'll write a little lambda function that we'll call our method. You don't need to understand the lambda functions. Great if you do. You can just copy paste. There's also some good examples of how they work in the Unity documentation. Alright, now we'll drop back to Unity again. Assign our panel. We'll create a text. And center that and pick a font size that actually works for us. Let's just let Unity pick it. Drag that in. And now we hit play. And there you have it. Drag it up. There's the flame sword. There's the gold helm. The ice sword. As you can see, as we drag it around, it automatically updates and changes. Thank you for watching. If you're interested in more tutorials, check out my channel. Like and share the videos. And place any questions you have in the comments, and I'll try and answer them as soon as possible. Thank you very much for watching.